mencapai misi yang satu, permisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hai, bismillahirrahmanirrahim. Assalamualaikum, salam sejahtera, selamat petang dan selamat datang ke Pusat Tuisyen Akademi Youtuber Malaysia. Bermula percuma, selamanya percuma. Apa khabar diucapkan kepada semua para penonton, ibu bapa, guru-guru, terutamanya kepada anak-anak pelajar yang kami kasihi sekalian. Di mana jua anda berada, kami doakan anda sentiasa berada dalam keadaan yang sihat sejahtera. Okey, jadi sebelum kita mulakan kelas pada petang ini kepada yang beragama Islam, mari kita mulakan dengan Ummul Kitab, Al-Fatihah dan doa belajar. Bagi yang bukan Muslim, anda boleh bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin, amin ya rabbal alamin. InsyaAllah mudah-mudahan kelas kita pada petang ini mendapat berkat dan memberi manfaat kepada semua yang mengikuti. Okay, jadi seperti biasa pada hari ini Ahad 3.30 petang, sekali lagi kita akan kongsikan kelas fizik tingkatan 5, kelas fizik tingkatan 4, iaitu pada petang ini kita akan ada tajuk yang masih lagi di bab yang keempat, iaitu standard kandungan yang ketiga, 4.3 specific latent heat. Jadi siapakah presenter kita pada petang ini? Cikgu perkenalkan Sega orangnya di sana berada di Melaka, iaitu Cikgu Peh KH ataupun yang lebih dikenali sebagai nama Mr.Peh. Sihat Mr.Peh, apa khabar?
Okey, khabar baik.
Baik, okey. Jadi Mr.Peh kini berkhidmat di Kolej Tingkatan 6 Tun Fatimah Melaka. Okey, dan saya sendiri Cikgu Hasnitah selaku moderator pada petang ini. Sebenarnya saya menggantikan Cikgu Yani sebagai moderator kerana atas faktor kesihatan beliau tidak dapat bersama-sama dengan kita pada petang ini. Jadi jom sama-sama kita doakan mudah-mudahan Cikgu Yani diberikan sebaik-baik kesembuhan. Okey, Cikgu Hasnitah kini bertugas di SMK Bagan Jaya, Butterworth, Pulau Pinang. Okey, jadi sekali lagi kelas kita pada petang ini adalah secara langsung dibawakan oleh Akademi Youtuber dan dikuasakan oleh Kelab Guru Malaysia dan EDD Malaysia. Jadi jom kita kongsi-kongsikan lagi link kelas pada petang ini di media sosial anda. Mudah-mudahan lebih ramai lagi. Jom ajak semua rakan-rakan kita sambil-sambil kita berhujung minggu, kita dengar-dengarkan apa yang bakal dikongsikan oleh Mr.Peh pada petang ini. Okey, dan insya-Allah sekiranya tidak ada masalah teknikal, kita akan kongsikan link kelas di hujung siaran nanti. Dan anda juga boleh respon pada ruangan chat sekiranya ada pertanyaan ataupun ingin menjawab soalan daripada Mr.Peh. Okey, dan satu lagi kita nak bagi tahu Mr.Peh. Mr.Peh ada kongsikan link PDF, kopi bahan yang disampaikan pada petang ini. So anda boleh klik pada link yang tertera pada skrin, boleh download, muat turun dan cetak keluar bahan yang disediakan oleh Mr.Peh ini. Okeylah, jadi dengan tidak membuang masa lagi, saya persilakan Mr.Peh untuk meneruskan. Silakan Mr.Peh.
Okay, so good afternoon everyone. So I am Mr. Peh. Currently I'm teaching at College Tingkatan 6 Tun Fatimah Melaka. So as mentioned by Cikgu Hasnitah, we are going to continue our journey in chapter 4. So the subtopic today will be 4.3, specific latent heat. And for today's lesson, we will have about 5 learning standard going to learn. So later on, I will explain to you what is the learning standard are going to learn later on. Okay, so as usual, here I would like to introduce you and let you know. So we have two online class, free online class physics. Okay, so the physics form 5 will be held on every Friday, 9:30 p.m. So currently we are already at subtopic 4.2, Arohan electromagnetic present by Cikgu Izyan. So you may go to channel Cikgu Izyan for the subtopic, okay? And then the another class will be as usual like today. So will be present by me, okay? And the class will be here on every Sunday, 3:30 p.m. So this is the Panitia Fizik SPM, Akademi Youtuber Malaysia. So today together with me will be have Cikgu Hasnitah. So thank you, Cikgu Hasnitah, for having me today. Okay, so before we go to the Learning Center 1, okay, so let us recall back what we learned at Form 1, because this is the foundation you are going to learn for subtopic 4.3 today. So actually at the Form 1 syllabus chapter 5 metal section 5.2, so regarding the kinetic theory of metal, so you already know that so the metal is actually exists in 3 states, which is the solid, liquid, and gas. And the heating and cooling can cause changes in the state of metal. So metal change from one state to another state when heat is absorbed or released. So you can see from the picture, this is the picture I take from the Form 1 book, textbook. Okay, so you can see when heated or heat is absorbed, so the state of the metal will be changed from solid, then to liquid, and then to gas. Okay, you can see the distance of the particles at the solid state is arranged closely together, and the distance of the particles getting further when the heat is absorbed by the particles, because they gain kinetic energy and able to move more freedom. Okay, then the third, when a substance is heated, the temperature increases. The particles in the substance will gain energy, move faster, and move further apart, as I mentioned just now, right? Okay, so the temperature is a measurement for the kinetic energy of the particles. So when the particles move in higher speed, so the kinetic energy increases, so the temperature will be also increases. Okay, and then the fourth, when a substance is coated, the temperature will decreases. The particles in the substance lost kinetic energy, move slower and closer to one another. So you can look at the figure here, blue color arrow here. So gas, initially where the distance between two particles is further apart, when they lost energy, so they will be move more slower and become closer to one another until when they touching each other, they will be form solid state. Okay, then number 5, therefore temperature is a measurement of the average kinetic energy of the particles of the substance. So as I mentioned just now, if the kinetic energy increases, temperature will be increases. And then the next here, this is also the picture I take from the textbook of Form 1. Okay, so here you can see that the temperature will be not change, okay, when reaching freezing point, melting point, and boiling point during the freezing, melting, and boiling. So from this figure, you can see the freezing is at here. Okay, so the freezing point for water will be 0 degrees Celsius. Okay, so at this temperature, so the water will be changed to solid, but the temperature is not changes. So as I mentioned just now, temperature is a measurement for the kinetic energy. So when the temperature no changes, so that means that the kinetic energy of the particle is remain the same at 0 degrees Celsius in liquid state of the water and also the solid state of the ice here. Okay, so here the kinetic energy of the particle do not increase during change of the state. So for example, change from solid to liquid through the melting process, it also occurs at 0 degrees Celsius. So the heat absorbed or released during the changes of the state without change of the temperature is used to overcome or form the force of attraction between the particles. In simpler say, there will be the bond, bond formed between two particles. For example, for water molecule will have the hydrogen bond. Okay, so as mentioned just now, we are going to learn 5 learning standards in today's subtopic. So the first learning standard will be, you need to know how to explain the meanings of the latent heat. Okay, so the definition for the latent heat is very easy here. There are 2 keywords you need to write in your definition. So there is the heat absorbed or released at the constant temperature during the changing state of the of a substance. So here the 2 keywords here will be the constant temperature and changing state. Okay, so here you can see they are the process occur when a solid where the ice at temperature -8 and heated to become steam. So we go through heating process, which you already learned together with Cikgu Hasnitah. So the heat absorbed will be cause the changes of the temperature. So you can see from -8 to 0. So the heating process here will be absorbing the heat energy. So we'll be using Q equal to mc theta. Okay, and then here, as mentioned just now, so the melting process will be the process where the substance changes the state or phase without changing the temperature. So you can see here, the state is from solid to liquid and the temperature is not changed. Okay, so this will be latent heat absorbed by the solid here. And again, when the water already formed completely after the melting process, so again, when we give the heat, so the heat will be absorbed as Q equal to mc theta. Okay, then the temperature will be changes. Okay, then from the liquid form of water change to gas form of steam here. So you can see again, temperature is the same, but the state is changes. So here we have the boiling point. So the boiling point will be occur at the fixed temperature. Okay, so here will be another latent heat involved here. Okay, so that means from solid to gas, so the heat will be absorbed. Okay, so when involve the changes of temperature, so using formula mc theta. So when the heat absorbed without changes of the temperature, but change of the state here, so we involve the latent heat. So this will be vice versa for a process from gas to solid. So from here you can see again the condensation will be the process where release the heat to surrounding, and the temperature is also not changed, which is still maintaining 100 degrees Celsius, but the phase is changed from the gas to liquid here. Okay, and then the cooling process here, where involve the same phase but change of the temperature, will be again the heat will be using Q equal to mc theta to find. So what is the heat released here? Okay, and then freezing, you can see again the temperature is the same, but the phase will be changed. So this will be involved releasing of the latent heat. Okay, and again from the solid to solid here. So you can see there is no change of the state, but change of the temperature. So this also involving Q equal to mc theta. So simply say, for the absorption of heat and the releasing of the heat, they will be involving the theory you learned in 4.2, which is using the formula Q equal to mc theta. And then involving the latent heat you are going to learn today. Okay, and we will have discussion where we have 2 types of different latent heats later on. Okay, so exponential just now we have two terms are going to write in your definition. So the constant temperature. So what is the meanings of constant temperature? As I mentioned just now, they will be maintaining the temperature. Okay, when absorb or release the heat, but involve the change of the state. Okay, and then here you can see another two. Just now I also highlight already. Temperature still maintaining, but the state is different. Okay,
Okay,
so
Mr. Peh, sorry to interrupt.
yeah,
We have one question here from Ng Jun Yen. He's asking, what is the difference between specific heat capacity and heat capacity?
heat capacity. Okay, so this one is it the last chapter, last subtopic is it? Okay, so
Yeah,
for the
correct.
heat capacity will be the heat absorbed or released, okay, to surrounding where involve the changes of temperature, but the state will be remain the same. Then specific heat capacity is also the same. Heat absorbed or released at the change of temperature in the same state, but is involved in the substance where is only 1 kg.
Yes,
Okay,
correct.
so I hope that I answer the question. Okay, from Junyuan. Okay, so the next here. Okay, as I mentioned just now, will be changing of state. Here will be from water to steam, where will be liquid to gas at the same temperature. Another one here will be the changes state between solid and liquid with same temperature here. Okay, so the first point here, the constant of temperature. So here we will be have emphasized latent heat is absorbed or released to overcome or form the force attraction between the particles. Okay, so at form 1, we just mentioned heat is absorbed or heat or released, but at form 4 here, we need to emphasize the heat involved here will be latent heat when the heat absorbed or released not cause the change of temperature. So why the temperature is not changed? Because the heat absorbed is used to overcome the attraction between the particles. For example, the hydrogen bond between the water, okay? Or release the heat when the water will be reform the bond hydrogen and the particle will become more closer together, okay? Okay, so latent heat is absorbed or released to not increase average kinetic energy of particles, as I mentioned just now. So the temperature is measurement for the kinetic energy of particles. When there is no temperature changes, so the kinetic energy and temperature will be the same. Okay, so the average kinetic energy of particle remain the same, therefore temperature will be the same. Okay, then the second, changing the state. Okay, so the changing of the state here involving melting or freezing here, where will be between liquid and solid here. Okay, so melting and freezing will be changes state between solid to liquid or liquid to solid. Here you can look at the figure. For example, melting will be solid to liquid, then freezing will be changed from liquid to solid. Okay, so the latent heat of fusion is absorbed or released to overcome or form the force attraction between the particles. So for sure that melting point will be absorb the latent heat to overcome the attraction. Okay, while for the freezing point, the heat will be released so that the force of the attraction between the particles will be reformed. Okay, and then the next here will be between the boiling and condensation here. So there will be the state changes between gas and liquid. Okay, so here boiling and condensation will be the state changes between liquid to gas or gas to liquid here. So latent heat of vaporization is absorbed or released to overcome the form the force of the attraction between the particles. Okay, so here, what I want to emphasize here will be just now, if the heat absorbed or released between solid and liquid, we know as latent heat of fusion. Then for the heat released or absorbed between the gas and the liquid, there will be latent heat of vaporization. Okay, so we'll go detail later on for these two terms. Okay, so we have complete our first learning standard. Okay, so now we go to our second learning standard. So will be, you have to able to define specific latent heat. So where the formula here will be Q over M, the symbol L referring to latent heat. Okay, then the specific latent heat of fusion, so the L will be together with F, which is represent as the specific latent heat of fusion. And the specific latent heat of evaporation will be with LV here. Okay, so the difference here will be between latent heat, just how we learned already. Okay, so heat release or absorb, okay, cause the change of the state, but remain in temperature. So again, here when we go to specific, so the mass will be referring to 1 kg, which I just now also give the explanation for the specific heat capacity and the heat capacity. So just involving 1 kg of substance when we're referring to specific here. Okay, so the definition will be like this. Okay, so specific latent heat with symbol L of a substance is a quantity of the heat using symbol Q, okay, that absorb or release during the change of the phase of 1 kg. Okay, you see 1 kg of a substance without any changes in its temperature. So the main difference here is we add on 1 kg in our definition for the specific latent heat. Okay, so here, look at the tips here. So the greater the value of the specific latent heat of a substance, the more heat is needed to absorb or release by the substance to change the state or to break or to form the bond between the molecule. Okay, so here, so some of the students, they still don't know what is the value indicated by the specific latent heat. So specific latent heat actually is a measurement for a substance where we can indicate that the substance able to absorb or more heat, okay, to break or form the bond, okay, between the particles. Okay, so here you can see the formula related to specific latent heat will be this formula, L equal to Q over M. So the Q referring to quantity of heat absorbed or released. Then the M will be referring to the mass involved. Okay, so an object of substance M absorb a quantity of heat Q during a change of the phase. For example, change from solid to liquid through the melting process. So you can see here, the latent heat is absorbed. While the changes of phase from liquid to solid, so the process involved will be freezing, and the latent heat here will be released. Or more specification, this heat involved is actually latent heat of fusion. Okay, so on the other hand, the latent heat is absorbed from liquid to gas via boiling process. Then the vice versa here will be latent heat released, okay, when the condensation occur and the gas will be changed to liquid. Okay, again, the temperature will remain the same. And the more specific latent heat here will be latent heat of vaporization. Okay, so again, here the formula, just now I already explained, will be involved in the calculation later on at Learning Standard 5. Okay, so the unit SI, very easy. So the unit SI for energy will be joule, for the mass will be kg. So SI unit will be joule per kg. Okay, so here, Okay, so as mentioned just now, okay, we have the two different type of the specific latent heat here. So the first will be specific latent heat of fusion. Is a measurement, okay, for changes between solid and liquid. Another one will be between gas and liquid. Okay, so here the definition for the specific latent heat of fusion will be like this, no? So specific latent heat of fusion with symbol LF of a substance is a quantity of heat that is absorbed during melting. Or you can state as changes from solid to liquid lah. Or quantity of heat released during freezing, here will be from liquid to solid. Or 1 kg. Okay, 1 kg of the substance without any change in temperature. Okay. Then for the specific latent heat of vaporization, definition will be specific latent heat of vaporization with symbol LV of a substance is quantity of heat is absorbed during boiling. So it will be from liquid to gas, or quantity of heat released during condensation. So it will be from gas to liquid of 1 kg. Okay, of the substance without change in temperature. Okay, so this is the process involved for the specific latent heat of vaporization. And melting and freezing here will be referring to specific latent heat of fusion. Okay. Okay, so the next here, okay, we are going to discuss the heating curve. Okay, so the first here we have AB. Okay, so the AB here, you can see the line represent the substance is in solid state. Here you can see S referring to solid. So solid is heated until melting point. So you can see here will be melting point. If let's say the substance here is ice, so the melting point here will be 0 degrees Celsius. Okay, so we will be, maybe A will be from -8 lah. Then until 0, when the heat absorbed, so the solid will be started to melt at point B here. Okay, so from here you can see heat is absorbed, and because of the involved of the changes of temperature, so the heat absorbed here referring to Q equal to MC theta, which you learn in learning sentence 4. Subtopic 4.2. Okay, then the temperature is increases. For example, here -8 of ice increase its temperature when heat is absorbed will be reached the 0 degrees Celsius. So from here, when there is a changes of the temperature, so that means the kinetic energy will be changes. Here will be involved increase of temperature, so that will be increasing of the kinetic energy of molecule. Okay, so next will be BC here. So you can see BC, the temperature is remain the same at point B until C. And the substance here now is at solid plus liquid state at the middle. Okay, so from here, BC, you can see melting point. Melting process is occur where the solid will change to liquid. So at point B here, so the solid start to melt, as I mentioned just now, and then C, the solid will be completely melted and become liquid. Okay, here the temperature is remain the same, but involve the changes of the state where from the solid to liquid here at BC. So that means the latent heat of fusion is absorbed and used to weaken the bond between the molecule. As I mentioned, if let's say this is a water molecule, so the bond between the water molecule will be hydrogen bond here. Okay, and the heat absorbed will be using this formula, ml. M will be mass of the substance. LF here will be the latent, specific latent heat of fusion of the substance referring to. Okay, then the next here, molecules are released from their fixed position and move throughout the liquid. So that means the substance or the molecule here will be initially slowly will be arranged closely compact together, just like the figure here. Okay, just can vibrate at the fixed position. Okay, and when gain heat, so you will be able to move more freely. Okay, but still do not gain enough energy to move randomly like gas. Okay, so here kinetic energy of the molecule does not increase so that the temperature is remain the same. So here will be constant temperature. Okay, then the next here will be referring to CD. So you can see here when at point C, the substance is already completely melt and become liquid. And CD involving same phase but different temperature, right? So here will be involving again Q equal to MC theta. Okay, so you see liquid is heated until the boiling point. So here will be the boiling point. So that means here, if I say referring to the water, will be 100 degrees Celsius. Again, heat is absorbed, temperature increases, the kinetic energy of molecule also increases. Okay, and then the next step going to discuss here will be DE. So the DE will be, again, you see the state of the substance is mixed, liquid plus gas here. Okay, L referring to liquid, G referring to gas. So the substance started to become gas at point D and completely changed to gas at point E. So here will be detail. So the process here involved will be boiling process, where changes the state from liquid to gas. Okay, then liquid start to boil at D, and whole liquid has boiled at E, so become gas already lah. Okay, so here the latent heat of vaporization is absorbed to break the bond between the molecule, and the heat here involved is Q equal to mL. So latent heat of vaporization with the M mass of the substance, LV here will be the specific latent heat of the vaporization of substance. So molecules are spread far from one another. Okay, just like the figure here you can see. So the distance increases. So the kinetic energy of the molecule does not increase at point E lah. Okay, so the temperature is remain the same. Okay, so the last here will be G. So the gas is completely freedom like this already lah. Okay. Okay, then here will be the cooling curve. So actually it will be reverse lah. So again, you can see S is liquid, S is solid, L is liquid, and gas indicate as gas lah. Okay, so the first here will be in gas state. For example, just now the gas may be at 100, 110 maybe. Okay, so we cool down. Okay, so will be reach the boiling point. So you see gas cold to boiling point. So here the heat will be released because of involving changes of temperature. Okay, so we're using MC data for calculate the heat release involved here. Then temperature decreases because the kinetic energy of molecule decreases. Okay, so again, using this formula to calculate the heat involved. Okay, then the next here will be BC. BC will be here. So here will be mix of the gas and liquid. Okay. So the process here will be condensation. So B will be the point where the gas is started to condense. Okay, so still in gas form lah. Okay, and then the whole gas has condensed to liquid form will be at point C. Okay, so the latent heat of vaporization is released, and molecule bond will be reformed again. Okay, with the heat release you want to get, you may using this formula ML. So M, mass of the substance. LV will be specific latent heat of vaporization of the substance. Okay, so the molecule move throughout the liquid. So that means here the molecule will be able change from randomly free movement to more closely together. Okay, so kinetic energy of the molecule does not decrease. So the temperature will be remain the same, where here will be boiling point. Okay, then the CD here, you can see already involve only same state. Here will be liquid. Phase will be same. Temperature will be from boiling point drop to freezing point when the heat is released to surrounding. Okay, then here the next will be DE. You can see again the D and E involve the same temperature but change in the state. So here is a mix of the solid and liquid. Okay, so the process involved here will be freezing. So liquid start to freeze at point D. So will be still in solid state at D, completely melt at completely freeze at sorry, here will be liquid. D will be liquid, then E will be completely solidified or freeze, become solid at E. Okay, so the latent heat of fusion is released so that the bond between molecule is strengthened. So will be close to one another and vibrate at the fixed position already. Okay, so the heat involved will be MLF. So M, mass of the substance, LF will be the specific latent heat of fusion. So the molecule vibrate around the same position. Okay, so the kinetic, same position. Okay, so the kinetic energy of molecule does not decrease. So the temperature is constant. So the last here will be from E to F. Okay, so the cooling process continue. So involving the decreasing of the temperature. Okay, so here is one of the activity in your textbook. Okay, so this is activity 4.6, page 140. So here, the aim is to discuss two things here will be the specific latent heat of the ice and the wax. Ice will be here, wax will be here. Second will be discuss the specific latent heat vaporization of the water and petrol. So water and petrol will be here. Okay, so the first question here will be compare the specific latent heat of fusion of ice and wax. Then we state the difference between ice and wax in terms of strength of the bond between the molecule. Okay, so here the wax is referring to actually the candle. Okay, actually we have the wide range of the wax here. So the carbon numbers can be from 16 to 36. So that means this will be a very long hydrocarbon chain. Okay, so when we discuss about the long hydrocarbon chain, so that means here will be involving non-polar molecule. So the bond involved here, the intermolecular force involved here will be van der Waals forces. Okay, as you learn in chemistry, when the van der Waals forces, when the size of the molecule increases, so the van der Waals forces will be increases. So that means here, although the wax is hydrocarbon, which is non-polar molecule, so the wax is still in solid form due to the big size of molecule, where contribute to the stronger van der Waals forces. Okay. Okay, then here you can see when we compare the specific latent heat of fusion, so you can see that the ice showing greater value of the specific latent heat of fusion. Okay, so the answer, first comparison between ice and wax. So the latent heat of fusion for ice will be greater based on the figure. Okay, then second, we have to discuss about the strength bond between the molecule. Okay, so here as mentioned, So the bond between the molecule for the wax will be van der Waals forces, while the ice will be hydrogen bond. Okay, so here, if we discuss about the strength of the bond between the molecule, actually, we need to accurate compared to you comparing the specific latent heat of fusion here. Okay, so here the bond strength of the molecule of the ice will be actually less than the wax if you're comparing their melting point. Okay, so here how we prove that? So because some of the students ask me, okay, so teacher, why the specific latent heat of fusion for the ice is greater, but the boiling point is lower? So actually here we can calculate their heat involved. Okay, so for 0 degrees Celsius of ice change to 0 degrees Celsius of water is only involving latent heat. So if we compare 1 kg of the ice here, so we calculate by substitution the value. So we get the heat involved is actually 3.34 times 10 power 5. But here, when we comparing for the bond strength, we have to comparing per mole, but not per kg. So when we change to per mole, so they will become 6,012 joule per mole. Okay, then we comparing to the wax here. So I search the internet, okay. So the specific heat capacity for the wax will be about 2,000. So here we involve 2 heats here. So here will be from 0 degree Celsius to is melting point. So it's about 53 degrees Celsius. So here we have the range 46 to 68 due to we have a wider range of the hydrocarbon number here. As I mentioned, when the hydrocarbon is increases, so the molecule size is bigger. So the van der Waals forces will be greater. Okay, so here if let's say I take 53 as the melting point, for example, paraffin wax here, so actually we'll be comparing the same from 0 degrees Celsius. So firstly must be including heat absorbed with MC theta, then only go to ml. Again, I comparing for the 1 kg of the wax here. So let's say we comparing the heat involved per kg. Actually, you can see the Q is actually slightly greater for the wax compared to the water here, ice here. So, but the melting point is showing greater difference between the ice and the wax here. But we change to mole for the wax, so you can see the difference is very big. So this showing that when we comparing the strength, we have to compare melting point. And here can be proved by the calculation I show you here. Okay. Okay, and then the next question. Okay, so here, as I mentioned, so you can see the Q involved per mole for the water, for the ice is actually lower compared to the wax. So the strength for the ice is less than the wax here. Okay. Okay, and then the next here will be the second question, comparison between the specific latent heat or vaporization for water and petrol. This is the first question. Then second, difference between the water and petrol in terms of the bond of strength. Then third, the distance separation between the molecule in gaseous state. Okay, so again, we're referring to table, so we'll be referring to these two. So again, you see, water will be showing greater specific latent heat of fusion or vaporization. Petrol will be lower. Okay, and then the melting boiling point for water average actually is higher compared to petrol. Okay, so the petrol range will be 35 to 200. Okay, so here, firstly, the question is easy. So we just look at the figure. So we can see the specific latent heat of vaporization of the water is greater than petrol. Okay, then Second here, the bond strength between the molecule of water is greater than petrol. Okay, we can compare based on their boiling point. Okay, and the petrol hydrocarbon numbers involved is normally will be 5 to 12, which is smaller than wax. So that's why you can see the wax will be in solid form because the strength of the van der Waals forces for bigger molecule is greater. Okay, so they can see petrol will be in liquid form because the strength is weaker due to the smaller size of the non-polar molecule of petrol here. Okay, so here you can see I give the hot tips. This one is related to chemistry actually. Okay, water molecule bonded with hydrogen bond which is stronger than the weaker van der Waals forces. Okay, so normally if comparison with between the small size of two molecules, so hydrogen bond is actually stronger than van der Waals forces due to the electronegativity of two atoms involved. Hydrogen and oxygen is a big difference, so creating the stronger hydrogen bond. Okay, however, van der Waals forces where will be normally weaker in smaller size, but if in bigger size like wax, so the van der Waals forces will be increases. So we can compare wax and the petrol based on the same type of the force, but different type of the size. Okay, then the second here, the latent heat absorbed. Latent heat is absorbed to the latent heat is absorbed to provide the energy to overcome the bonding force between the molecule. Okay, so here, the smaller the latent heat, the easier the bond can be break. So that means here the petrol showing smaller latent heat, right? Okay, so that means it will be more easily to break. So the distance for the water molecule is actually smaller than petrol due to more harder to be break. Okay, then the last here for the activity 4.6 here. Okay, so for specific substance, why specific latent heat of vaporization larger than specific latent heat of fusion? So here we can compare ice and water. So you can see ice, this is water. So the number is 22.6. Then for ice will be 3.34. So here showing that specific latent heat of vaporization is greater than specific latent heat of fusion. So why? Okay, so the answer will be like this now. So the energy required to complete separate molecule moving from liquid to gas will be this liquid to gas, and solid to liquid will be this. And the distance separation for liquid to gas here is actually involve greater distance, but for the solid change to liquid, the distance involved is very small. Okay, so hence the latent heat of the vaporization, which involving separation or reducing, increasing of the distance is higher from gas, from solid to, from gas, liquid to gas here. Okay, so the specific, so the latent heat of vaporization for changing the liquid to gas is greater than the latent heat of fusion. Okay, so here we go to learning standard 3. Okay, so how we can determine the specific latent heat of fusion of ice and the water. So here we have two experiments involved. Okay, so the first one will be at your textbook, so page 141. So is to determine the specific latent heat of fusion of the ice here. So the apparatus involved will be like the figure here. Okay, will be immersion heater, crushed ice filter funnel, retort stand, beaker, and water together with power supply here. Okay, so the material used must be crushed ice here. Okay, because the crushed ice used to increase the contact between the ice to the heater. So that means heater will be this. So it's smaller ice, so there will be close to the heater. So the efficient heat transfer will be allowed between the ice and the heater here. Okay, so the procedure will be as usual like textbook. So place the beaker for experiment set. So here we have two sets. One is the experiment set and one will be the control set here. Okay, on the electronic balance respectively. So we have to weight their mass. Okay, reset reading of both electronic balance to 0. So this is the first step. Then second, set up the apparatus as shown in figure. So it will be like this. Initial, the both beaker and electronic balance are not below the respective filter funnel. So that means after we weigh, do not put both the beaker and electronic balance under the filter funnel here. So that means we don't want to collect any liquid first. Okay, and then here, next will be switch on the immersion heater for the experiment set only. So you switch on here. Okay, so when water is dripping out from the filter funnel at the fixed rate, so place the beaker of the electronic balance respectively below the filter funnel, start the stopwatch. So that means when the dripping of the water, okay, at the experiment set is already constant, so you just started your stopwatch. Okay, then we have to wait for 10 minutes, okay, to collecting the water, and we measure the mass, where the mass for the set experiment will be M1, then control will be M2. So the control will be do not have any power supply. Okay, so that means here the ice melted is due to the temperature surrounding. And then the experiment set, we have two heat supply. One will be the heat from surrounding, one will be the power supply. Okay, then switch off the immersion heater and record the power. So the power of the heater have to observe the power rating in the label of the immersion heater. So here the correcting data, okay, so the data here is just a reference data where I did together with my students previous year ago. Okay, so again, the M1 will be the mass for the water collected for experiment set, which is about 0.081. Okay, and the M2 will be control set, where the water is collected due to heat provided by surrounding. So it will be 0.13. So power, you can just read the power rating label, okay, on the heater, okay, and then it's 50 for my experiment now. And then the time second here will be 10 minutes converting to second will be times 60, become 600. Okay, so we need to calculate the latent heat of fusion of the ice using the formula. So here will be PT, where it come from, P equal to Q over T. You learn at PT3, so we rearrange, you get this value. Okay, heat provided by heater. Okay, so we substitute the value, so we get 4.41. So M1 minus M2 indicate this is the water melt by the power supply only. Okay, because we already minus out the effect of the heat from surrounding, where it come from M2. Okay, so conclusion. So our specific latent heat of fusion here will be about 4.41 times 10 power 5. So here you can see the actual value is about 3.34. So our experiment value here is greater than the actual one. Okay, so why? So you can see the value of the specific latent heat of fusion of ice determined by experiment is greater than actual. Normally we will get greater now. Okay, so because some of the heat from the heater is dissipated into the surrounding. So because when we give the heat, so not all the heat is touching the ice. Some is actually not providing the heat to ice, is to air. So that means there is a heat dissipated to surrounding. Okay, so here we can actually calculate how much a heat loss here. So you can see for my experiment, Q equal to PTs represent the heat provided by the heater, right? So we get 30,000, where I multiply P times T lah. Then the actual heat absorbed by the ice, how many? So we can using formula Q equal to ml. But here, the mass loss, mass collected is 0.068 times the actual specific latent heat of fusion of ice here. So we get 22712. So the loss is about 7,288. So it's about 24.29% loss through my experiment did by my student here. Okay, so therefore the mass of the ice melted is less than expected. Okay, so then the second here will be the experiment 4.3b to determine the specific latent heat vaporization of water. So here, again, we're using the apparatus listed here. Also, the high power immersion heater is used. Just now one, I'm using 50. So here will be 500 stated in the textbook. We just follow. Okay, and then also others apparatus stated here, and you can see at the figure. So procedure, set out the apparatus as shown in figure. Okay, switch on the immersion heater and wait until water boils. So you switch on. Okay, then we need to wait until the water is boiled. Okay, so when the water boils, start the stopwatch and at the same time record the reading of the electronic balance. So that means we need to get the mass just the first second when the water is boiled. So we can actually using thermometer to measure when the temperature of the thermometer reach about 100 degrees Celsius. Okay, so here you can use thermometer to measure boiling point to indicate the water is actually boiled. Or you can look at the bubble, okay, appear at the beaker. Okay, and then here I changed the experiment to 1 minute. Okay, because maybe my beaker is too small already. Okay, so it's too long time if I say I follow 5 minutes. So this is the data for my students now. So I do some changes. I'm using 1 minute to record. Okay, and then switch off the heater and record the power. So here, what's the possible error of the experiment? First will be the steam on the heater may condense back. So when touch the surface, coastal surface, so the steam will be changed back to liquid and then drop back. So the mass calculate or measure will have error already. Okay, or some of the water can be spilled out. Okay, can be spilled out. So actually you can using more deeper beaker to avoid the spilling of water. Okay, when the water is boiled. Okay, and then here you also can look at the figure. We need to cover the surface of the beaker by tissue. Okay, so that we can reduce the heat loss of surrounding. Okay, so this is a measurement I get. Firstly, will be when the water is started to boil, T equal to 0. So I get this mass. Okay, and then second, when 1 minute, I get 0.044. The water must be evaporate already, right? So the mass must be decreases. Then I using 1 minute, so the time taken is 60 seconds. Again, with the power rating, which is 500. Okay, so I'm using the formula and PT over M1 minus M2, just take the textbook. Okay, so you can see the value I get will be 23.1 times 10 power 5. So again, so the reading where I get here will be smaller, it's greater than the actual. So the actual is 22.6. So I get slightly higher. So it's more accurate for this experiment compared to just now one. Okay, so here the specific latent heat vaporization of water determined by experiment is greater than actual. So again, this is due to the heater. The heat from the heater is dissipated into surrounding. Again, I can calculate by using the same method, PT, for the heat provided by heater, okay, which is here. And then I'm using the loss of the mass times the actual specific latent heat of water. So I get the loss, I get the heat absorbed is actually less than the provided. So that means the heat loss is also occur, but here is quite good. The loss only 2.07 loss here. Okay, so here the discussion, why does a control set need to be prepared for experiment A but not B? So you can see here, the set experiment A, we have the control set, but B, we do not have any control set. Oh, okay, so why? You can see compared to our LF and LV. So the LF is smaller compared to LV lah. Okay, so you can see the heat from the surrounding to the heat to heat the water is very small. So that means we want to use the heat from surrounding to boil the water is actually impossible, right? Okay, so we can actually not need to count in the effect of the heat surrounding. Okay, because the heat surrounding is very small to convert the water to water vapor. Okay, and negligible lah. Okay, then number 2, given specific latent heat of fusion of ice here is with this value. Compare the value of the specific latent heat of fusion. Okay, explain the difference. Just now I already show you lah. Okay, so our one is slightly greater than the actual. Okay, why? So it's because some of the heat from the heater is dissipated to surrounding. Okay, so the heat loss I also showed already just now. Okay. Okay, and then here, number 3, given specific latent heat of vaporization, so the actual 22.6 times 10 power 5. So again, the actual I get slightly higher. So here, the experiment value is greater than actual. So it's also due to the heat loss to surrounding. Okay, again, I also can calculate the loss for the experiment by using the same method I explained just now. Okay, and then number 4, suggest a way to increase the accuracy of result for experiment A. So experiment A, the first precaution. Actually, okay, so here hot tips here will be the precaution normally will be asked at paper 3. So how you write the precaution, you have to give the method to gather the reason. So here will be first, small crushed ice must be used. This is a method. Reason, to increase the contact between the ice and heater so that give the better heat transfer between ice and heater here. So this will be reason. The second here will be ensure all parts of the metal cylinder immersed into ice. So that means metal cylinder will be, this is a heater, right? So the metal parts will be here. Make sure all is immersed into the ice. Okay, so that the heat provider is used to heat the ice, not heat the air surrounding. So here again, this is a method. This is a reason. Okay, and then the next here will be the suggestion for the experiment B. So again, precaution, we need method plus reason. So you can see, look at the figure, we are cover the outer surface of beaker with tissue so that we can reduce the loss of heat to surrounding. Okay, or again, make sure the cylinder, here cylinder metal of the heater must be immersed fully. Okay, so that the heat provider is used to heat the water, not the air surrounding. Okay, so Cikgu Hasnitah, we can take a break.
Okay, Mr. Peh. Okay, student, don't go away. We will right back after this short commercial break. Okey, kembali lagi bersama kami dalam siaran langsung kelas tuition online percuma bagi subjek Fizik SPM Tingkatan 4. Anda sedang menyaksikan siaran ini dari dua channel YouTube, iaitu yang pertama channel YouTube Cikgu Peh KH atau Mr.Peh, dan yang kedua kita juga sedang bersiaran dari channel YouTube Cikgu Yani. Jadi kepada yang belum subscribe kedua-dua channel tersebut, sila subscribe sekarang dan berikanlah sokongan anda kepada Mr.Peh. Okey. Dan jangan lupa aktifkan notification button for all supaya anda akan mendapat info terkini mengenai video-video yang dimuat naik oleh Mr.Peh, dan begitu juga dengan kelas-kelas online beliau. Okeylah, kita teruskan. Mr.Peh, silakan.
Okay, so thank you, Cikgu Hasnitah. Okay, so we continue to our another last two learning standard. I try to speed out. Okay, so the learning standard 4 here, we need to communicate to explain the application of specific latent heat in our daily life. So here I'm going to discuss two applications where also actually stated at the textbook here. So the cooling system in refrigerator and also the evaporation of the sweat here. Okay, so the first application here will be specific latent heat in our daily life. Okay, so for application of the specific latent heat, so you have two basic theory you need to understand. So the first will be the absorption of latent heat during melting and evaporation can be used to give the effect of cooling. Okay, so what means by this? So that means that we can using the latent heat, specific latent heat, to give the cooling effect by absorption through the process of melting and evaporation. So on the other hand, if I say your purpose is to produce the heat, okay, so you can using the process of condensation, okay, so that you can release the heat through the process and get the heat you want. Okay, so for the cooling system in refrigerator, actually both of the concept, the cooling effect and heating is actually occur, okay, at the application of refrigerator here. So basically, the refrigerator is actually uses the cooling effect from evaporation. So you can see here, the evaporator coin will be given the cooling effect for the refrigerator. Okay, then normally the HCF liquid, or we know as liquefied hydrofluorocarbon, will be used as a cooling agent. So firstly, because it is easily to evaporate, so that means they will be have actually the low melting point, and then secondly, the latent heat, specific latent heat is actually greater, so can be absorbed or release more heat. Okay, so during the circulation of cooling agent, so the cooling agent here will be referring to HCF lah. So the heat will be absorbed inside the refrigerator, referring to evaporator coin here, so that given the cooling effect to inside the refrigerator. Okay, so be here absorption of latent heat inside the refrigerator through the evaporator. Okay, and then here you can see the heat is released outside. So you can see here we have the Q release. So here the heating effect, you can feel the heat when you close to the condenser. Normally you're behind the refrigerator or under the refrigerator. So this will be behind. So you can see the condenser coin and vent fin here is responsible to release the heat, which is absorbed at the evaporator here. Okay, so here will be the more specific discussion regarding the working principle of the refrigerator. So here we have the four main parts. Here will be first will be the evaporator at the top part, okay, of the refrigerator. And then here we have the compressor. And then here we have an expansion valve and also the condenser. So the condenser for this picture will be at the bottom. Just now one is actually behind the refrigerator, but different location, the application is the same. Okay, so first the compressor will be compress the cooling agent, okay, to increase pressure and its temperature. So the first compressor, the main purpose here will be actually compress the cooling agent. Here will be the HCl, so that the temperature and the pressure will be increased. So here will be in gas form. You can look at the red color arrow and the flow represent as a gas state. Okay, then second, the condenser cooling agent here will become warm, okay, because of the compression compress the gas already. Okay, so releases heat, latent heat to surrounding during condensation. So that means the condensation will be occur at the condenser. So the heat will be released to surrounding. Okay, then third will be the expansion valve. So the expansion valve just now is at the top. So here is at the bottom, but same function. Okay, so the cooling agent here will be become liquid already okay, because the heat already released. Okay, so here will become liquid. Okay, so the valve restrict the flow of the refrigerants. Refrigerants here will be cooling agent, causing cooling agent expand. Okay, so just now condenser release the heat. When come to here, the expansion valve will be restrict the flow of cooling agent. Okay, and then cause the cooling agent to expand. And here will be leading to decrease in pressure and temperature. So will be changed to liquid. Okay, then the next here will be the fourth part. So now you can see the blue arrow from the expansion valve. Okay, so the cooling agent now already in liquid form. Okay, and then flow to the top here will be the evaporator. So in the evaporator, the cooling agent is in liquid form, evaporate and absorb latent heat of fusion inside the refrigerator. So although you see the arrow, blue arrow is out, come from the refrigerator, but actually the heat is absorbed into the evaporator and release the cold air. Okay, so as the warm air from inside the refrigerator passes over the cold evaporator coin. So you can see here we have the evaporator coin. So the heat is absorbed from the air in the refrigerator to cooling agent. So this causes the cooling agent to evaporate and transforming back to low pressure gas. So here you can see after the evaporator, so the cooling agent or HCF here return to become gas again. Okay, so here the cooling agent where will be in gas form will be flow up from the evaporator and to compressor again. So the cycle will be completing again. Okay, then the second here will be the evaporation of the sweat. Okay, so again, just now we say that will be have two effect will be showing, or two application is involved. One will be cooling effect and one is the purpose of the heating. Okay, so for here, evaporation of sweat bring to cooling effect. Okay, because of the sweat will be absorb the heat from the body. So here is only involve the cooling effect. Okay, so we sweat on hot day or while doing heavy work. Okay, so when sweat evaporate, heat is absorbed from the body, causing cooling effect. Okay, so the rate evaporation can be increased when there is air circulation. So that means we have when surrounding with strong wind. So the cooling effect will be increases . Okay, so we go to our last learning standard. So here will be the problem solving involving latent heat. Okay, so here with 3 questions. So one question, calculation. Another 2 questions. One will be from part A, another one will be at part B . Okay, so the first question is a calculation. Okay, so how much energy has to be removed from 0.2 kg of water, 10 degrees Celsius to produce block of the ice at 0 degrees Celsius. So this statement given you 2 heat is involved. From changes of the temperature with same state we involving Q equal to mc theta, heat capacity. Then the second, when involve same temperature, different state, we involve the latent heat. Here will be the latent heat of fusion because the process is from liquid to solid. So total energy release will be mc theta plus mlf. So we substitute 0.2 given by question, 0.2 mass. Okay, and then C is here. Changes temperature will be 10 to 0. M will be 0.2, L will be here. So NR we get 75,200 joule. Okay. Okay, then the next here will be the question 2. Is the question from trial SBP last year. Section A, question number 4. Okay, so diagram 4 shows an electric steamer. What is the meanings of specific latent heat of vaporization? Okay, so normally the first mark involving definition. So be the heat required to change 1 kg of the liquid to gas without any change of temperature. Okay, so here the water will be changed to gas when when get the heat lah. Okay, so this is the definition involved. Okay, and then second here will be B, water in the steamer of 0.5 kg with an initial temperature of 25 degrees Celsius is heated until it boils. So what is the change of temperature? So here boils referring to 100 degrees Celsius, boiling point of the water. So the changes here will be 25 and 100. Okay, so will be 75 degrees Celsius. Very easy, this question. Okay, then the next here, calculate the quantity of heat required. Okay, so here, see the question given you, specific heat capacity. So heat involved will be mc theta lah. Okay, so from the question just now, given that the m equal to 0.5 and the temperature changes will be 75. So we just substitute in the formula mc theta. So we get this value, 157,000 per joule. It's very straightforward question. Okay, then number 3. So the food in the steamer require 4.8 times 10^5 joule of heat to steam. Let's calculate the mass of the steam produced. Okay, so here, steam produced here will be the vaporization of latent heat involved. Okay, so we using formula Q equal to ml. The question asks us to calculate the m will be here. So you need to rearrange the formula. And the Q given as 4.8 times 10^5. Then L will be given here. So you just substitute. You get your answer, 0.212 kg. You can give your answer in minimum 2 decimal places with correct unit. Okay, then here will be the theory, 3 marks. Using concept of latent heat, explain how food is cooked with electric steamer. Okay, so here the first, you can discuss the energy changes for the steamer is from electrical energy to heat energy. First mark, or you can give water is boiled and produce steam. Second mark, condensation is occur. Okay, so will be changed from gas to liquid. Okay, so the large heat is produced. Okay, so the heat is released to surrounding. Okay, so the heat is produced through the condensation. Okay, so the heat produced will be transferred from the steam to the food. So that means the food is absorbed the heat released by the steam through the condensation process. Okay, because the condensation process is a process release the heat to surrounding, and the heat produced is used to transfer to the food, so the food can be cooked okay, after receive the heat. Okay, so we go to our last question, 20 mark question here is Trial of Terengganu 2022. Question number 9. So diagram 9.1 shows a glass of the water cooled by using some ice cube. This process involves the specific latent heat of fusion. Okay, because involving the state changes between solid to liquid. Okay, so here what is the specific latent heat of fusion? Just now the example is specific latent heat of vaporization. Okay, so here the definition for latent heat of fusion. Okay, so the amount of heat required change 1 kg. When discuss specific, we need to give the mass of the substance from solid to liquid without changes of temperature. Okay, then the next here will be the theory 4 marks only. Okay, using concept of specific latent heat, explain how the cube can cool the drinks more effectively. So first mark, temperature of the ice lower than water. Second, ice cube absorb heat from water. Then change from solid to liquid when the ice is melted. Okay, and then latent heat is absorbed by the ice to weaken or break the bond between the molecules. So here, 5 point maximum you get 4 marks. Okay, and then the next will be calculation. Okay, so the water in the glass in diagram 9.1 has mass 0.2 kg. Initial temperature 50 degrees Celsius. Some of the ice cube have melted. So melted, that means will be 0 degrees Celsius. Okay, so what is the heat absorbed? So here will be involved Q equal to MC theta. Okay, where the heat is released by water. So we substitute M C theta will be 50 minus 0. So we get 42,000 joule. Then next will be the mass of the ice that is melted. Okay, so the heat released by water will be equal to latent heat absorbed by ice. So again, using Q equal to ml, so the latent heat absorbed is equal to the heat released by water. So L given as this value. So you just substitute, then rearrange, you will get M equal to 0.1257 kg, or you can give 0.13 kg also can. Minimum 2 decimal places with correct unit. Okay, so step 1 assumption that you have to make in above station. So the heat is not released to surrounding. So we need to assume, although this is not a real condition. Okay. Okay, so we go to the last 10 marks question here. Here will be the decision making question. Okay, so you can see table shows the 4 refrigerant panel P, Q, R, and S here. So P, Q, R, and S. So they condense of coolant agent flowing through the condenser pipe. Okay, so here we discuss the condenser pipe and the cooling agent here. As mentioned just now, we give the example HCF . Okay, so explain the suitability of each cooling panel feature for cooling the refrigerator quickly, determine the most suitable cooling panel, and give your reason. Okay, so this is a refrigerator just now. Okay, so here we'll be mainly explaining the condenser fixture. So we need to choose the shape is straight or coin. So ratio actually is coin. And then the specific heat capacity. So that means we want to see what type of the specific capacity you choose for the condenser coin. So you can see condenser coin here is coin. Okay, so answer ratio will be coin. Okay, and then the next will be the cooling agent. So we need to choose specific latent heat, higher or lower, and its boiling point. Just now I actually already explained what you have to choose. Okay, so the first, we need to choose the high specific latent heat of the vaporization. Okay, you have to choose high. You just copy all the terms here, give high. Reason, able to absorb or release large amount of heat during the phase change. This one just now I explained already. And then the boiling point must be lower lah. Okay, must be lower, so that the ability to turn into gas easily when it's absorb heat. Okay, then the next shape, as mentioned, we will be using coin. Okay, so to increase the surface area, so the heat will be released to surrounding more easily. Then specific heat capacity must be low lah, so that transferring of heat will be in faster rate. Okay, must be high. Must be low. Must be low. Okay, must be low. Okay, here is low. So we need to choose low specific heat capacity of the condenser pipe. Normally it's metal so that the heat will be easily transferred to surrounding. Okay, we can release heat more easily. So here will be choose R. So the last mark here, we just copy all the character at the box here. So you will get full marks for decision making question. Okay, so that's all for my sharing. Thank you. So I pass back to moderator, Cikgu Hasnitah.
Okay, thank you very much Mr. Peh. Terima kasih di atas perkongsian itu tadi, sangat padat dengan info dan contoh-contoh soalan daripada SPM tahun lepas yang berkaitan dengan topik. Okey, jadi para pelajar, terima kasih di atas usaha anda, dan sekarang cikgu saya kongsikan link sijil. Anda boleh isikan link berkenaan menggunakan email EDD ataupun email MOE ataupun email D5. Okay, dalam tempoh 30 minit selepas kita tamat bersiaran sebentar lagi. Okay, so pautannya telah ada pada skrin, anda boleh rujuk, boleh klik pada link tersebut dan isikan mengikut maklumat yang betul lah. Sila isikan dengan maklumat yang betul dan anda akan terus terima sijil tersebut menggunakan email yang anda isi tadi. Okey, jadi sekali lagi terima kasih kepada presenter kita Mr. Peh, begitu juga dengan yang terus setia bersama kita daripada awal tadi sehinggalah sekarang hampir ke pukul 5 petang, hampir sejam setengah kita bersiaran pada petang ini. Jadi alhamdulillah, mudah-mudahan apa yang dikongsi oleh Mr. Peh tadi memberi manfaatlah untuk semua yang mengikuti kelas kita pada petang ini. Jadi Mr. Peh, minggu depan kita akan bercuti
Yeah.
So untuk pengetahuan anda, kita akan bercuti minggu hadapan dan kita akan kembali lagi bersiaran seperti biasa pada 8 dan 10 September. Okay, so jangan lupa persiaran kembali pada 8 iaitu pada hari Jumaat 9.30 malam. Kita akan bersama dengan Cikgu Rosemawati untuk tajuk yang seterusnya, tingkatan 4, subjek tingkatan 5. Dan untuk 10 September, sekali lagi kita akan bersama Mr. Peh untuk tajuk yang seterusnya 4.4 Gas Law. Okey, jadi teruskan menyokong kami di Akademi Youtuber. Sekali lagi, siapa yang belum subscribe channel Mr. Peh, boleh tekan butang subscribe di bawah, berikan like pada siaran ini dan jangan lupa kongsikan kepada rakan-rakan anda. So pada siapa yang masuk lambat tadi, yang anda terlepas bahagian awal, jangan lupa anda boleh tonton semua siaran ini dan boleh pauskan pada mana-mana bahagian untuk anda lengkapkan link PDF yang dikongsikan oleh Mr. Peh. Cikgu kongsikan sekali lagi link bahan kita pada hari ini. Anda boleh dapatkan latihan PDF pada pautan berikut. Okey, dan sekali lagi jangan lupa isikan sijil menggunakan email MOE D5 atau EDD anda. Okey, Mr. Peh, ada pesanan terakhir tak untuk pelajar sebelum kita berundur diri?
Okay, so minggu depan kita akan masuk holiday kan. Okay, so selamat bercuti lah kepada semua. Dan hari ini punya topik sebenarnya saya rasa sangat laju lah. Okay, sebab sebenarnya ada banyak isi yang mana pelajar pernah tanya saya. Dan saya tak pernah lagi ada sempat kongsikan. So saya harap melalui apa yang tadi saya kongsi, so dapat membantu kepada semua lah. Selain pelajar juga cikgu-cikgu lah. So sekiranya ada apa komen yang mungkin salah ke, so bolehlah kita belajar dan kongsi bersama. Okay, thank you.
Okey, terima kasih Mr. Peh. Okey, jadi itu sahaja siaran kita pada petang ini. Sekali lagi, terima kasih kepada semua. Saya sebagai moderator menyusun jari. Memohon ampun sekiranya ada tersalah bahasa dan tersilap tutur kata sepanjang saya mengendalikan kelas pada petang ini. Sesungguhnya yang baik daripada Allah. Segala yang kurang itu daripada kelemahan dan kedangkalan ilmu kami. InsyaAllah kita jumpa lagi dalam siri-siri yang akan datang. Assalamualaikum, salam sejahtera dan bye-bye semua.